lesson, we'll be discussing explicit arithmetic sequences. At the end of the lesson, you should be able to write a formula for an arithmetic sequence and find any term in that sequence. An explicit equation, you have to be able to identify the first term, and then you're going to need the common difference. And then what position are you looking for? Are you looking for the third term? Are you looking for the 10th term? Are you looking for the 100th term? So in the equation, a to the n equals a to the 1, that's our first term, plus the common difference, d, times whatever position you're looking for, minus 1. So if you're looking for the third term, everywhere you see n, you're going to put in 3. So the difference between the recursive and the explicit, in the recursive, you use the previous term to find the next one. So you just go in order and follow the pattern. In the explicit, that's when we have the first term, but we want the nth term. So the nth term means that position. So if we want the 100th term, we might not want to use recursive because we would have to go through the entire pattern. So remember, in our mnemonic device, explicit goes with multiply. So you're multiplying the common difference times that n minus 1. In word problems, you have to identify the first term. And if in the word problem they're giving you something about an initial value, that's the 0 term. So you're going to have to add the common difference to get that first term. Remember, you're looking for your common difference. You need to write your equations, and then remember with word problems, if there are words in the question, you need words in the answer. So for writing an explicit equation for the nth term, first, you have to find the first term. That's your first job, is to find out what the first term is. Then you find the common difference. Then find n, what position you're looking for. Plug in the values into the equation, so your term, and then simplify. So first examples. The first one says, write a recursive definition for the explicit formula. So what it's asking you to do is take it from the explicit formula to the recursive formula. So the recursive formula is the one up here in the red. From the explicit, I can see that this is my first term, and this is my common difference. So when I write my recursive formula, it will be a to the n equals a to the n minus 1, and all I have to plug in is minus 5. In the second one, I'm going from an explicit, I'm trying to find explicit, I've been given the recursive. So from the recursive, I can tell that the first term right here is -2, and I can see that my common difference is common difference of 6, so I'll rewrite this as a to the n is equal to the first term, so a to the first term is -2, plus my common difference, n minus 1. All right, next one. Given the first term and the common difference, find the first 5 terms, and then write the explicit form and use it to find an indicated term. All right, so my first 5 terms, I'm starting with, this is my first term, so it will be 9, 17, 25, 33, because my common difference is 8. So if I rewrite this as an explicit form, it would be a to the n equals 9, that's my first term, plus 8 is my common difference, n minus 1. If I'm looking for it to the 14th, right here, the 14th term, so then I write a to the 14th, that's the term number I'm looking for, 9 plus 8's my common difference, and I change this to 14 minus 1. So that's 9 plus 8 times 13, which is 9 plus 104, so a to the 14th is 113. Oops. The local radio station had a contest where listeners would win money. The contest started at $1,000 and 97 was added every time the previous caller answered incorrectly. How much could the 18th caller win? All right, so my first term, A1, is 1,097 because I initially started with 1,000, so term 1 is 1,097. My common difference is $97. So if I put it into my equation, a to the n equals the first term plus the common difference times n minus 1. And so if I put 18 in for n, they will win $2,649. If there are 20 rows of seats in a concert hall, 25 are in the first row, 27 in the second row, 29 in the third, and so on. How many seats are in the last row? And then if the concert was sold out, how many people attended the concert? So the first term, the first row, has 25 people, 25 seats. And then it looks like every time we're adding 2 more. So our common difference is 2. So if I write my equation, a to the n is my first term plus my common difference of n minus 1. Now I know there are 20 rows, so 25 plus 2 times 20 minus 1. That's 25 plus 2 times 19. So that's 25 plus 38 is 63 in the last row. So if we wanted to know if it was sold out, we would add the rows. 25 plus 27 plus 29 plus 31 and so on. Plus 63 would be the last one, and that would equal 880. All right, let's match up which one is the recursive and which one is the explicit form. So the first one, when we see this first term of -3 there, we know that that has to be the recursive. In the second one, we don't have the first term. Our first term is written over on the side where it says A1 equals 5. So that means it's explicit. And the next one, again, we have A1 equals 2. That's telling me the first term is 2. That's explicit. In the next one, the first term is 4, and then our common difference of n minus 1, that's recursive. In the next one, again, we have our first term is 5, and our common difference is 3, so that's recursive. And at our last one, we're given the first term of 6, so that's explicit. Does the explicit or the recursive require the first term? The recursive does. Does the explicit or the recursive, the first one is previous term, and then this one is the first term. So recursive needs the previous term, and explicit needs the first term.